Hello there students, welcome back. Let us discuss about the Kossel approach to chemical bonding. So Walther Kossel has given some important postulates to understand the chemical bonding based on the electronic configuration of noble gases, which has a stable 8 electrons in the valence shell. The configuration is ns2np6. Okay, so the first point which will be discussed in Kossel approach is in the periodic table, highly electronegative halogens and highly electropositive alkali metals are separated by noble gases which do not react, which have the stable octet configuration. Okay, so on the one side you can have the highly electropositive alkali metals, and on the other side we have the highly electronegative halogens, and both are separated by the unreactive elements that are classified in a group, that is zero group. Those are noble gases. So right, so that is the first point in Kossel approach, right students. Then what could be the second point? So in the second point he is describing the formation of cations and anions, that is positively charged ions and negatively charged ions. So formation of negatively charged ions from the halogen and positively charged ions from alkali metals is associated with gaining or losing of electrons by the respective atom. So for example, okay, so here we have the alkali metal sodium which loses electrons and it produces positively charged ion, okay, and there is release of electron. Okay, similarly here we have the halogen chlorine atom. So this chlorine atom is going to gain the electron and it is going to convert into chloride anion, which is a negatively charged ion. Okay, right. So in the second point he is describing the formation of a positively charged ion and negatively charged ion by the loss and gain of electrons respectively. Okay. The negatively charged ions and positively charged ions attain stable noble gas electronic configuration, as we have said in the previous point. So the main goal of losing an electron by the sodium or the main goal of gaining of electron by the chlorine atom is nothing but to attain 8 electrons, a stable noble gas electronic configuration of 8 electrons, that is ns2 np6 in the valence shell, in the outermost shell. Okay, right. The noble gases have a particularly stable electronic configuration of 8 electrons, ns2 np6. Okay, so if you observe the noble gas elements except helium, remaining elements will be having the 8 electrons in the valence shell, where the configuration, electronic configuration, will be ns2 np6. So with this you can say that the noble gases are very stable. Okay, so the remaining elements will try to achieve the 8 electrons in the valence shell, either by losing electron or gaining electron or sharing of electrons or by transfer of electrons or donation of electrons. Okay, so that is the procedure where the elements of except noble gases will try to achieve the 8 electrons in the valence shell, that leads to the stability of the particular element. Okay. The negatively charged ions and positively charged ions are stabilized by electrostatic forces of attraction, which keeps the unlike charges together, as you know. So in this present case, sodium is converted into positively charged ion, chlorine is converted into negatively charged ion. So because these two are oppositely charged, they are not like charges, they are opposite charges, they are having opposite charges, positive charge and negative charge. So they will be attracted together, and this attraction force is called as electrostatic forces of attraction. Okay, so this electrostatic attraction force will keeps the two charges, that is positive charge and negative charge, together, and they exist as a single molecule, that is sodium chloride. So sodium ion, positively charged ion, and chloride ion, negatively charged ion. So because these are oppositely charged, there will be some attraction force, and with that attraction force they are held together as a single molecule, that is sodium chloride. Okay, right. Then such electrostatic forces will result in electrostatic bond, or it is also called as ionic bond in such a molecules where you can see the positively charged ion and negatively charged ion. So there will be a bond between them, a chemical bond, and that bond is electrostatic bond or ionic bond. Okay students, right. Now let us see the a simple formation of this sodium chloride. You know that sodium is having the atomic number 11, electron configuration is 1s2, 2s2, 2p6, 3s1. So in the valence shell it has 1 electron, whereas the chlorine atomic number 17, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. In the valence shell you can find 7 electrons. Okay, if chlorine, if sodium loses 1 electron, that is if the valence electron present in the 3s orbital, if it is transferred to the valence orbital of 3p, okay, of chlorine, so the sodium will be having the 8 electrons in the valence shell, that is noble gas configuration, noble gas electronic configuration. Similarly, the electronic configuration of chlorine will becomes 3s2, 3p6. So 6 plus 2, 8 electrons. Okay, it is also the noble gas configuration, so that they will attain the stability. Okay, so sodium is going to transfer the electrons to the valence shell of chlorine, so that sodium is converted, Na is converted to Na plus, that is positively charged ion, where the electron configuration is 1s2, 2s2, 2p6. So in the valence shell, now the 2s2, 2p6 is the valence shell. So in the valence shell you can observe 8 electrons, that is it has achieved the noble gas configuration of ns2 np6. Similarly, the chlorine by accepting, by gaining electron from because sodium has transferred the electron, the chlorine is converted to chloride, a negatively charged ion. So in the negatively charged chloride ion you can see the valence shell electron configuration 3s2, 3p6, 6 plus 2, here also it has 8 electrons. Okay, so by this transfer of electron from sodium to the from the valence shell of sodium to the valence shell of chlorine, so there is formation of positively charged ion and negatively charged ion. There will be some electrostatic attraction force, and there is formation of ionic bond between them, students. And as well as the sodium has gained 8 electrons in the valence shell, and the chlorine also gained 8 electrons in the valence shell, so that they will attain the stability. They have achieved the inert noble gas configuration of ns2 np6. So that is the formation of sodium chloride, which can be easily explained by the Kossel-Lewis approach of chemical bonding, which is a very fundamental topic in understanding the chemical bonding, students. I hope you liked this video. Thank you for watching.